Isaac Newton's three laws of motion are foundational principles that explain how objects behave under various forces. Newton's first law of motion, often termed the law of inertia, states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This principle means that, in the absence of a force, an object's velocity will not change. It won't start moving if it's at rest and won't stop or change direction if it's in motion. For instance, a book lying on a table will remain there unless someone or something moves it. Similarly, if a spaceship travels in space, it will continue on its path indefinitely unless an external force like gravity or a collision alters its trajectory. Newton's second law of motion, known as the law of acceleration, is articulated by the equation F equals ma, where F represents the net force applied to an object, m is its mass, and a is its acceleration. This law delineates that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. Essentially, it means that the heavier the object, the more force is required to accelerate it. For example, pushing a car requires significantly more force than pushing a bicycle to achieve the same acceleration. This law is fundamental in understanding how the velocity of an object changes when it is subjected to an external force. Newton's third law of motion, commonly described as action and reaction, posits that for every action, there is an equal and opposite reaction. This indicates that forces always come in pairs. If one body exerts a force on another, the second body exerts an equal and opposite force on the first. A practical example of this is when you push against a wall, the wall pushes back with an equal force. Similarly, the recoil experienced when firing a gun is the result of the bullet being propelled forward and the gun being pushed backward with equal force. These three laws collectively form the cornerstone of classical mechanics, offering a comprehensive framework to understand and predict the motion of objects in our universe.